So for someone listening, maybe wanting to break into one of these fields or perhaps level up, what are the ways in? How do you actually build these skills?
Right. Navigating this definitely needs a bit of strategy. Your sources lay out, well, both the traditional academic routes and these increasingly important alternative ways to qualify, which is great news, especially if you're thinking about changing careers.
Let's start early then. What about high school students? How should they prepare if they're interested in this?
Yeah, building that strong academic foundation early on is just critical. The absolute core subjects are computer science, mathematics, and statistics. And it's not just about passing the classes. These subjects teach the fundamental logic, the analytical thinking that underpins everything in data science.
Which specific math topics are most important, would you say?
Linear algebra, calculus, and definitely probability and statistics. That's the theoretical bedrock. Understanding those helps you understand how the algorithms actually work later on. In computer science, getting some programming experience, especially with Python if possible, is a huge advantage. But honestly, even a solid foundation in programming principles using another language, like Java and AP Comp Sci, is great. Python syntax is relatively easy to pick up once you have those fundamentals. And high school is also a great time to start playing with data science concepts directly. Learning about collecting data, cleaning it up, analyzing it, visualizing it, maybe trying small projects, analyzing some public data sets. Just cultivating that critical thinking and data literacy early makes a big difference.
Okay, what about university? Are degrees still the main path? And how necessary are advanced degrees like masters or PhDs?
Formal education is definitely still a primary route, yeah. And your sources strongly suggest an increasing emphasis on advanced degrees, especially for those more specialized roles or leadership positions. For a general data science role, a bachelor's in something quantitative data science, CS, math, stats, engineering is often the entry point. But as we noted earlier, the data suggests many careers, particularly the advanced ones, are increasingly asking for a master's or even a doctorate. That rise in job postings needing graduate degrees. It signals the field is maturing, and for certain competitive roles, a bachelor's might not be enough anymore. It pushes people towards higher ed for that deeper theoretical edge. For a machine learning engineer, a bachelor's in computer science, software engineering, or something similar is usually the minimum. But again, a graduate degree often provides that extra depth and project experience that can fast-track you to senior roles and better pay. It gives a competitive advantage. For a data engineer, most entry-level spots need at least a bachelor's. CS, engineering, even business with a tech focus are common. Degrees specifically in data science or analytics, with coursework in databases, data modeling, big data, highly relevant. For moving up, a master's focusing on data systems, analytics, or an MBA with an analytics track is often preferred or even required for more senior roles. For an AI engineer, given the complexity, a bachelor's in CS or data science provides the foundation. But for really understanding AI principles deeply and tackling those cutting-edge challenges, a master's or PhD in AI, ML, or a related field is highly recommended, especially for research or highly specialized roles, and for those specialized data scientists. While a quantitative bachelor's is common, many of those high-paying specialist careers increasingly require an advanced degree. Master's programs in applied data science, AML focusing on areas like computer vision or NLP or business analytics are very relevant. And it's worth noting, some master's programs are specifically designed to help people transition from non-STEM backgrounds too.
Okay, but what if someone doesn't have that traditional academic background? Or maybe they're looking to switch careers entirely. Are there other solid options to get the needed skills?
Oh, absolutely. This is where things like industry certifications and all the online learning platforms become incredibly valuable. They offer structured, flexible, and often very accessible routes to getting specific job-ready skills. This is particularly good news for career changers or people needing to upskill effectively.
Tell me more about certifications. How much do they actually help?
They can help a lot. Industry certifications act as a clear signal to employers that you possess specific, validated skills and knowledge they're looking for. Earning a respected certification, say from AWS or Google Cloud or Microsoft Azure, can really boost your marketability because it proves hands-on competence with their platforms. For machine learning engineers, cloud provider certs focused on ML are strong options, though some require prior experience. Certs from companies like Databricks also validate skills in specific ML tools and workflows. For data engineers, again, cloud platform certifications are really popular. Microsoft Azure, Google Cloud, AWS all have them. Your sources also mention some beginner-friendly options, like a metadatabase engineer certificate or programs like IBM's data engineering certificate that are specifically designed for career changers, sometimes with no prior experience needed. For AI engineers, certifications range quite a bit. You've got introductory ones covering AI fundamentals, sometimes without even needing coding skills. Then there are more advanced ones requiring Python and diving into specific techniques or deployment practices offered by IBM, NVIDIA, and others. And for specialized data scientists, platform certs like the Azure Data Scientist Associate validate cloud skills. There are also project-based professional certificates and nano degrees on platforms like Coursera or Udacity, which are great for building a portfolio and proving you can use tools like Python and SQL effectively.
Right. And what about online courses, those MOACs? There seem to be thousands out there.
Yeah, massive open online courses, MOCs, are fantastic for flexible learning. Platforms like Coursera, EDX, DataCamp, Udacity, they offer courses and full programs, often from top universities or tech companies. For machine learning, you can find comprehensive specializations taking you from beginner concepts to advanced deep learning, usually with hands-on coding labs using Python libraries like scikit-learn, TensorFlow, PyTorch. For data science, there are tons of beginner-friendly professional certificates covering the fundamentals: SQL, visualization, data wrangling, intro ML, using tools like Python and R. Google and IBM have very popular entry-level programs. For AI engineering, you can find courses covering everything from basic AI concepts to advanced deep learning, NLP, generative AI, MLOps, often tied to specific cloud platforms or tools. And for data engineering, platforms like DataCamp and edX offer structured paths covering SQL, database concepts, Python, big data tools like Spark and Kafka, and pipeline orchestration tools like Airflow. Many include practical exercises.
That's great. Are there also good free resources people can tap into, maybe just to start exploring or go deeper on certain topics?
Absolutely, tons. YouTube is actually an incredible source of high-quality free content if you know where to look. For the crucial mathematics for data science, channels like 3Blue1Brown offer amazing visual explanations of things like linear algebra or neural nets. Others provide great stats tutorials or break down the math behind specific algorithms. For ML and data science tutorials, channels like FreeCodeCamp, Data School, Data Professor offer practical guides using Python, Pandas, R. Others focus specifically on machine learning implementation. And for industry insights and advanced topics, you can find channels summarizing the latest research papers, doing deep dives into advanced tools, or featuring interviews with leading AI experts like Lex Friedman. These are fantastic for self-directed learning, staying current, and just deepening your understanding.
Okay, this has been incredibly comprehensive. So it really sounds like there isn't one single right path, but maybe different strategies work best depending on your goals and the specific role.
Exactly. That dual path seemed to emerge pretty clearly. You can aim for broad versatility, understanding and contributing across the data lifecycle, or you can choose to go deep, cultivating highly specialized expertise in one of those complex, in-demand AI subfields. Both are viable paths to success, but they might lead to different types of roles and earning potentials, especially right now with the AI boom.
And that choice between being a versatile all-rounder or a deep niche specialist.
Which really brings us to a final thought, a question for you listening. Given this rapid evolution and all these diverse paths and specializations opening up in data science, how do you decide? Which qualification method, which area of focus feels like the right one for you as you look towards your future in this data-driven world?